Hello viewers, in today's class we are going to discuss one important application of derivatives in proving important inequalities, right? So we already know that derivatives have vast applications in different fields of mathematics, or we can also say that derivatives can be applied effectively to solve different problems, right? So here we'll prove this important inequality with the help of derivatives, right? So here we have to show that x square minus 1 is greater than or equal to 2 times of natural log of x for all x greater than 0, right? So let us start. Now here what we will do, or what will be our method of doing this problem, right? So we'll consider a function f of x, right? So we'll take a function f of x is equal to x square minus 1 minus 2 times of log of x. So the first step is to assume a function of this form, which can be taken or which can be assumed from the given inequality, right? So we have x square minus 1 minus 2 times of log of x is equal to f of x, right? So now what we will do, we'll differentiate this function with respect to x, right? So we'll obtain the first derivative and then second derivative, right? And then we'll find out the critical points or the turning points, and then we will apply the second derivative test. So let us see how we can do this. So now differentiating f of x with respect to x, what we will get, f prime of x is equal to 2x minus 2 times of 1 over x. So the derivative of x square is 2x and derivative of log x is 1 over x, right? So we can write it like this: 2 times x minus 1 over x, right? Now let us find the second derivative of f of x, that is f double prime x, and we have 2, and derivative of x is 1, and derivative of 1 over x is minus 1 over x square, so this becomes plus, so we have 1 plus 1 over x square, right? So now we have these two derivatives. So now here let us apply the concept of maxima and minima, right? So maxima and minima can be applied here. So for the turning points or for the critical points, we can write f prime of x is equal to 0. So now this is equal to 2 times x minus 1 over x is equal to 0. We'll now solve this equation. So we have x minus 1 over x is equal to 0, that is x is equal to 1 over x square is equal to 1, and from this equation we find that we will have x is equal to plus 1 and minus 1, right? Okay, now in the given problem we have the condition x is greater than 0, right? So here what we will do, we'll reject this value of x, which is minus 1, right? So we'll accept only one value of x, that is x is equal to plus 1. So here x is equal to plus 1 is the turning point or the critical point, and now we will test whether this point is a point of maxima or minima, right? So for this we'll go to the second derivative test in maxima and minima, and we will substitute x is equal to plus 1 over here, right, in equation number 2. So let us see what we will get. So f double prime of 1, that is x is equal to plus 1, so we'll get 2 times 1 plus 1 over 1 square, right? So we'll have 2 here we have 1 plus 1, 1 over 1 square is 1, so we have 2 times 2, that is 4, right? So we see that we have got plus 4, that is greater than 0, right? So the second derivative at x is equal to plus 1 is greater than 0. So by second derivative test, we conclude that this point x is equal to plus 1 is a point of minima, right? So the function f of x attains minimum value at x is equal to 1. So now let us find the value of this f of x at x is equal to plus 1. So f of 1, which is the minimum value of f of x, that is f of 1. So we'll have 1 square minus 1 minus 2 times of log of 1, that is natural log of 1. So we have 1 minus 2 times 0, because log of 1 is obviously 0, and we have 0 minus 0, that is 0, right? So the minimum value of f of x is 0 when x is equal to 1. So now from this discussion we conclude that f of x, right, this f of x is always greater than or equal to 0 for all x greater than 0, right? And f of x is greater than or equal to 0 because f of 1 is equal to 0, which is the minimum value of this function at x is equal to 1, right? And obviously for x is equal to 1, f of x takes the value 0, right? So f of x is greater than or equal to 0 for x greater than 0 because f of x attains minima at x is equal to 1 and the value of f of 1 is equal to 0. So f of x will always be greater than or equal to 0 for all x greater than 0, right? So now if we take f of x as x square minus 1 minus 2 times log of x over here, let us see what we get. So we have x square minus 1 minus 2 times log of x greater than or equal to 0. So we can now write it as x square minus 1, taking this term to this side. So we have 2 times of log of x, right? And this is exactly the inequality which we have to prove, right? So this is how we see that with the help of the second derivative test or the concept of maxima and minima, we can prove important inequalities, right?